next speaker is here. Sergio de los Santos is one of our biggest heavyweights. I've been trying to convince him to be here in previous editions, and finally he is here. I keep having discussions with him. So thank you so much, Sergio. If you could introduce yourself. You can hear me, yes? Well, my name is Sergio de los Santos. And by the way, there are some rumors circulating. I can leave Malaga, my home city. I'm here. Okay, this is not a hologram of myself. It's me. I'm not particularly thrilled, but I'm here. Well, this is a presentation similar to something you could see back in December of last year. It was a really nice experience. We've been investigating along these lines for quite some time. I started doing this myself in 2015, when this was more or less new. So it's been quite an interesting journey so far. I want to leave it behind, but it's a really nice lesson learned. I think it's quite cool, actually. There's nothing absolutely spectacular, but it's interesting food for thought. Then talking about innovation and laboratory stuff at the cybersecurity unit for Telefonica Digital. We do our best to produce positive impact on the products and services that they sell, whilst we improve existing products and services. So how does TLS work? This is a very light explanation. It looks cool. These are not my slides anyway. If you're using clear text and there is a man in the middle, that man in the middle could access the passwords or any sensitive information that is moving throughout the network.
El SSL y el TLS se supone que te...
So TLS is all about protection, in theory. José Selvi, the previous speaker, has told us about the vulnerabilities that may exist in different protocols, including TLS. So, to keep things simple, against TLS, in general, I think there are two main common attacks. These are the two most frequent attacks. SSL strip, which is exploiting the fact that most pages are not using HTTPS for man-in-the-middle attacks, and then rogue certificates, which I'm sure you know about. Rogue certificates issued by a fake CA authority, embedded in your browser, embedded in your internal network, issued by mistake, whatever. These rogue certificates may be able to intercept communications. On top of that, we have the lack of trust in TLS. So, not so long ago, it was 2013, something like that, 2014, a couple of mechanisms, of security mechanisms, were implemented back then to add another layer on top of TLS. That's HSTS and HPHP. How does HSTS work? As you see on that big screen, when you access a site, you go to Netflix, for example, using HTTP, there is a location to HTTPS, and when you are in HTTPS, you get a header with that name, plus the expiry time, and your browser, obviously, will go to the SSL path through a 302. From then on, since the browser has that header, it will remember that it always has to go to it using TLS, to that website using TLS. And it does have the forward addressing, which is a 307, an internal 307. The SSL strip has nothing to do, can do nothing, because there is no open connection. There is an encoded connection, an encrypted connection using an internal 307. Because what the browser does is look into its own memory. You may try to force the browser to use the 302, but it doesn't use it. It will use the 307. What happens with the other one, the HPHP? Chrome has been working with this to get rid of it, actually. What does it do? We're talking about row certificates and HSTS attacking in different places. I'm not sure I'm moving too much. I was saying that rogue certificates was one of the most common attacks. You must remember the certificate you use to go into the website. It's really funny when people say, oh, there is a lock there. There is a lock icon, but no one remembers, because it doesn't make any sense, to make an effort to remember who issued the certificate. If someone changes the certificate for your bank and your browser, you wouldn't notice a thing. I mean, no one notices that, no one remembers that. Everything seems to be okay, there are no alerts. So if a rogue certificate is there, you will not notice a thing. What this does is to force the browser to remember the certificates. What the administrator does is when serving the certificate, it will issue a string through the header, bookkeeping through RFC, tells you that you need at least 2 pins. Pins are a representation of the certificate, in fact, the SPKI field. Not all extensions, of course. You may change the date, you may change other little things. So it would get too complicated. What this does with 509 is to sign the CPKI. It signs that, it hashes it, and it calculates the MD64. So now the administrator is given the option to choose one out of these 3 certificates, and from then on choose any certificate, but one of them must not be in the string, one of them must be for backup. When I say backup, it means that if you shoot yourself on the foot, you can change quickly. So it serves you one of those certificates. Those arrows are wrong, actually. One of them is given to you, maybe any one of those out of those 3, and the other one, which is a fake one. The browser will remember this and will say, okay, you told me to remember this one, and that one. As soon as the one that I'm remembering changes and doesn't belong to this group, I will show you an alert telling you something has changed. Now the administrator has to be smart. If you pin this one, which is changing very often, you will have to remember to change the one you use for backup and the one you're pinning. If you change this, which is not changing that fast, that's more suitable. But then you have an additional security problem. If there is a man-in-the-middle attack or the certificate is changed, they might issue one for the same CA by mistake. In fact, I saw someone issuing a fake certificate, a rogue certificate. So here you're less protected and it's more cumbersome. You're more protected, but it's very cumbersome, or you're less protected, but it's simpler. This is about determining the overlap between what you remember and the pins. So this is relatively simple. You need to have one for backup and one which is real, representing one of those 3. That's basically the whole summary for this. If at any point in time one of these certificates changes, you will get this alert. I don't know if you've seen this before. It's very clear.
Aquí al
So I've gone here to this third chain, and this is not what I was expecting, this is not what I was remembering, and I don't think you visited this before. So we are using this page, but this page that I'm showing you, this site is public, okay? So it is often used for video demos. So we've done lots of studies to find out who implements these, and you found terrible things as to how this is often implemented. We have went through Alexa. We've seen that many pins are badly inserted or put in place. So all that has been published already. I encourage you to visit our blog. We often post entries on Mondays and Tuesdays. But what I liked the most was the way browsers implemented it, okay? And this is what my presentation is about. When I could see how this was implemented by Firefox, that was in 2015, has remained the same. So there is a file site security service .txt, and when I Google site security service, I got an entry which was a source code. So no one was talking about it, there was no documentation about it, and I said, well, this is cool. So we found this, and we wanted to kind of decrypt it, okay? So there was no other documentation, just the source code. It is not always easy to look at it and to find out things. Actually, some things were not even implemented in the code. So we analyzed it little by little, and then we discovered that it stores domains, then it went through HSTS or HPHP. So this is a score. So this is the number of days, number of different days where you visited this site. So that means that if I visit it today, that will be 1. If I visit it again, I will continue to have number 1. But if I visit it tomorrow, I will have number 2. And if I visit it next time next year, it will be number 3. Okay, this is something that Firefox has invented. So we wanted to understand why they did that. Okay, so this is the number of days since epoch to conduct. They had a number of flags and domains, and then pins. Pins because it was a HPKP entry. It also showed us here because it was like really difficult. We just made a plugin for the browser to interpret the times, whether it will expire, whether it was reset, whether it is a domain. It also tells us about the pins. This is a plugin that parses TXT file. So it is there, available to you, so that you can download it and you don't have to go through all that crap. So, what did we find? So at the time, we found that the limit was set as 1024 lines, not domains, I mean lines. So therefore, a domain with HPKP and HSTS will occupy 2 entries, and we will only have like 1024 possibility and chances of storing things, and then your mind starts to think, why 1024, not another number? Okay, so the first question was, what happens if you try to fill up those 1024 entries with junk? Well, there are several ways to do it. So you just manipulate the headers of a site. So we had to prepare the cloud pinning. We asked it to resolve all the subdomains and to put it in the same place. We bought the relevant domains. We bought 2 domains to make changes in the domain headers. So the only thing that I did here was that I'm helping myself. I'm using cloud pinning. So what we did it with JavaScript, sending quick requests, and injects this JavaScript in any site. Okay, so therefore it will be filling it up with junk behind. So imagine that I visited Netflix or Instagram, and instead of TXT, I take a look at Pin Patrol and say, oh, Netflix goes through HSTS. So in theory, the attack should not be working because the visit will go through a 307 address, internal address. So with this attack, we just do man in the middle. I wouldn't win any bounty with it. Then you inject any JavaScript to any visited site. Then it starts to fill it up with headers, and that's it. So the victim visits any site. For instance, in this case, holamundo.es, where some JavaScript is being injected there. A few seconds or minutes later, the user, wouldn't notice anything whatsoever, and then browser may take 5 minutes depending on the configuration. And now if the victim uses our plugin to see what it remembers about HPHP and HSTS, actually we'll see these 1024 entries, and then it will see that Instagram entry is gone. So it has dehosted Instagram from the HSTS database. So therefore, we will have the opportunity now to carry a conventional man-in-the-middle attack, and that's why HSTS was stored in the browser. So let us say we have dehosted a domain from the browser, so therefore the host doesn't work anymore. Okay, now we will visit Instagram. We will not type in HTTPS. In theory, you should consult HTTPS, but it says, look, you wanted to go through HSTS or TLS, but you forgot to write it. Well, then so no matter the test that you make, then in clear text, you will see it like an SSL strip attack to Instagram. So we have kind of evaded or eliminated HSTS from any websites thanks to the implementation of Firefox. But some entries were not overridden. So filling that up with junk or overwriting it was kind of random. So everything comes from the score that was invented by Firefox. That explains us why they have come up with that score and why they are storing the different the different days that you have visited the website. So they disclose the source code and they explain the score. These are the comments for the source code. It says, well, the entry an entry score is incremented once for every day, and then the entry with the lowest score is evicted. When we will have lots of entries with the lowest score, any entry will be evicted because that will depend on the memory. That is to say, the way the memory is landing for the memory is being made. Okay, so we will evict the entry with the lowest score. So what does that mean? It means that the higher the score, the more difficult for you to be evicted. So what does it mean? that you will be more easily attack the sites that you visit unfrequently, whereas the most visited sites will be more difficult to evict. And then when we continue reading the source code of Firefox, they say it may happen that all the domains may have the highest score, so therefore we will not be able to evict anyone. The worst that will happen is that there are 1025 entries, so therefore the 1025th entry will be replaced every time. But that would not be that bad because you will have to end up modifying the file. Well, you will have to have very high scores and then having these 1025 entries. And I said, well, this will never happen. They said they would never happen. I said, yes, of course it will happen. So we started to invade that with our fake, to invade the scores with our fake domains. So we said, we thought, if we fill everything up with a sufficiently high score, we wouldn't need to reach 1025. We would try to evict those entries with the highest score, and at the end of the day, to be left with one slot only. So how would it work? I yank HSTS entries injection, and the next one I do the same thing, and then the score will be incremented by 1, so I could just send the same junk HSTS entries, and then it will be incremented by 2, and the process will be like that. And then I remember Jose's survey, and I said, okay, let us use DeLorean. That's what it is there for. Well, to increase it by the day artificially and to carry out an attack in a question of minutes. If we manage to increase the scores of these junk pages quickly, we will also be able to, or will be more likely to evict frequently used domains, and in the worst case scenario you will be left with one entry only. Okay, and now to go through DeLorean and to tell you how it goes. It is as follows, okay? DeLorean, and then we said one day in the future. Then we start listening. Remember that the DeLorean, in case you don't know, it is an MTP server. It simulates to be a server, MTP server, and this Ubuntu will ask for the time to the servers. It will be decided, and it will tell the server that we are in the future. So that with that future day, we just send in or inject the domains again. So we have a JavaScript injection visiting the fake domains again, and therefore we increase the score rapidly. If we go back to the victim site, we increase DeLorean and we set it to 2 days ahead of time. Ubuntu, that is the victim, will ask for time again to default server. The server says that we are 2 days ahead in time, and then we repeat the operation again. Well, requests were made quite frequently and quite fast as well in this Ubuntu. So for the server, it's already Saturday. Any visit that will be made through this injected JavaScript, it will have a feeling that they are on a different day, and then we will start to see an increase in the score of fake sites. So therefore, little by little, we will have the chance to evict entries with higher scores. You may end up saying, well, you may need, some scores may be very high, like 15, but other pages or other sites are like have very, very low scores. So sometimes when the scores are increased, okay, they are just reset to 0. That happens sometimes in highly frequency sites. Okay, so man in the middle plus DeLorean, not for Windows, plus HSTS. This is a very nice technique in those places where you are already in the middle. For instance, you are in a hotel with a Wi-Fi network. This is a hostile environment. So when you want to visit a page and you may just want to have that hack or to make that hack in the captive sites of the hotel, and if you are staying at a hotel, you will have a few days to experiment with it. You can also improve this attack by introducing some timing, that is to say, introducing the ones that you have visited, because you have the cloud pinning and you've seen the logs, you know which ones you have visited, and you can serve, you can deliver exactly the same them, and you can deduct, you can really see how long the table is, so that you serve the only what is necessary to end up with one slot only. We have not implemented it, but surely if we try it, we will succeed in doing it. Well, in the case we just don't want to evict any specific entry or domain, this is what will happen all the time. We will only have one entry. There was case the scenario in the Firefox comments made by the programmer fulfilled easily. Don't forget that this is really negative. When we have expiry date plus H high one, that always will stay, and the new entry is available for anything new. Anything new means that when you open up a Firefox site and then you get the box for favorites, that's already an entry. When you go to a site and it's full of ads, all that is taking up space. So in practice, that a single entry is all the time receiving a score 0. So that's for Firefox. And now forget about a score, because Chrome doesn't have any scores. Let us see how Chrome does that. Chrome supports or uses a JSON file. JSON file stores all the information about the site that is visited, and that's something which is interesting. It encrypts the domain, or actually hashed the domain. We didn't know how it did it, but we found it out. Okay, it's a hash base 64 hash. We built a plugin for the browser, but our browser knows which domain that is. It does it through visiting the history, and it compares it. So therefore it knows the domains that have been visited. So privacy is not very high, and the rest of data are here. A curious thing that we've found is the following. Contrary to Firefox, Chrome has no storage limit whatsoever. No type of limit. Firefox only allowed 1K. So 1024 below and to the side. So if you introduce the pin in Firefox to the right, you could only reach 22 or 23 pins. The rest of the pins are ignored because it doesn't want to store any more pins. Whereas Chrome, as we will see that now, it looks like an endless well. So endless, what happens if we fill it up with thousands and thousands of jack entries and pins and very long ones with lots and lots of pins in them? Well, that's what we did. We just decided to hide it here. Okay, by clicking on this button, you will go to cloud pinning, and cloud pinning will fill up 50,000 requests, each of them including a high number of pins. Okay, no, one true pin and 4,000 false ones. Okay, let us see what happens now. If you connect, it is going to cloud pinning. This is what is happening behind the scenes. Okay, the user apparently cannot see anything, and look, these are all the requests that are being made in the background. Well, the side effect is that this grows very quickly in megabytes. Everything is dumped in real time, doesn't go through the memory. Everything is stored in the TXT file, and the size of it increases significantly. So 25, 30 megabytes, this is real time. And you see the increase in the size of file. Actually, 10 minutes later, depending on your network latency, or less than 10 minutes later, we have 120 megabytes. Okay, so the user is still waiting. So we have reached 500 megabytes from a TXT. There is no limit. We could go on. 500 megas is enough. And then the user said, okay, in the meantime, I will visit another address, okay? This is real, okay? So it is frozen, okay? Chrome gets frozen. You cannot type in anything. Then you restart the browser, and you cannot type in anything again, okay? So you cannot use it. How could we use it? How could we go back to it? Remember, it's been frozen. If you manage to reach the history and to delete it, okay. Or rather, delete the TXT. Well, any user says, well, this is not working for me, I don't know what's happening, then we'll just go to Firefox, and then we will just launch an attack from Firefox, basically. Well, or the person will go to Internet Explorer, and we will also attack from Internet Explorer, which is easier. So this is very easy. Well, you do a man-in-the-middle attack. So with 300, 400 megabytes, so Chrome stops working in a few minutes. What happens with Internet Explorer? Okay, 25 minutes before I finish. Good. Well, of course, we didn't find any documentation for Internet Explorer, and then we got to this file, .dat. This is extensible storage Excel type of file. It is a type of database of Microsoft, for which there is no documentation whatsoever, no information about how it is stored or the type of database where it is stored. So we are a bit like lost, huh? So for name, we could, well, we are not expecting to find HPHP, not at all in Internet Explorer. So we don't expect to find it, because, well, Chrome is saying that it would eliminate HPHP. So Internet Explorer will just wait and see what happens, and, well, it was right, okay, because HPHP will be eliminated. So some domains are stored in here. We don't know, as I said, how those domains are stored, when it expires. I said, well, surely there is something fishy here. Okay, domain, well, surely this is associated with HTTPS. We don't know how it hashes that. Well, probably someone which is better at reversing could find that out. So it is complicated because we have to do that live. So what we did was just extremely simple tests. When you have, when you use Internet Explorer, you go to well-known sites, Facebook, Instagram, or Facebook, Google, Outlook. So it looks like it works. So you visited that first with no TLS, then you revisited it without TLS and did like kind of internal forwarding, and then, well, so let us send out lots of requests to CloudPin, see what happens, and we give the header back. We sent in 131 requests on the 25th of November, and sometime later, from, well, we didn't see any information about HTTPS. So nothing was being stored because the domain was not known. But when you visited known domains, it seems that there was some kind of changes in the table. And I said, well, something must be wrong in what we were doing, either the header, something was failing. And then when we did the live reversing, we could see that in winnet.dll, as I said, we had no documentation whatsoever. We had HTTPS hosts enabled, and then we could see methods that were kind of related to HSTS. So checking active, added, set it in the database. Well, these were calls, these were requests. These existed, but these ones were not calling each other. They were not being called in the ordinary workflow. But in any case, it looked like if it worked. If you visited something with no TLS, then revisited it through TLS, you could see that it worked. So our theory or hypothesis was that this was being cheated by or deceived by cache. So what was making everything running was the cache. And we did the following test. So we visited Instagram. So we eliminated cache, or we just restarted the browser. LibSoft is the only thing that allows you to read this table where supposedly Internet Explorer stores the HSTS values. So it hasn't done anything. And when you want to make an attack, you can easily attack Instagram by eliminating the cache. You don't have to eliminate the HSTS table, but just by eliminating the cache or by restarting the browser, you can already bypass the HSTS. But we were not clear about the sites that were remembered and stored, and actually what is confusing that some of the functions that should be called are not called. That's because of the cache effect, and also very confusing reading that Internet Explorer adds support for HTTPS, but actually this does not work.
Tan-
And we were so excited that we mentioned this during the Black Hat conference. And then Microsoft came along and said, you have been deceived. This will be on in June of 2018. We are actually testing it. Simply speaking, it doesn't work. They have it available for certain domains, they have the methods implemented, but they don't call each other. Okay, despite this. And this has been confirmed by Microsoft.
Nuevo que quedaba por ahí eran algunos resquicios de la implementación, de la investigación.
So this is the new part. People are asking me about the world of mobile. Well, this is the answer. If you're in iOS, forget about HPHP. Why? No idea. No one tells you that it doesn't work. In fact, if you take a look at the page, what can I use? In Firefox and Chrome, it works. No, under iOS, it doesn't work. Okay? In Android 4, which is a bit old, in Android 4, Chrome says it does work, it doesn't work. It's a lie. Okay? HPHP doesn't work in Chrome for Android 4.0. This is a small video clip to show you how it works. These are tests using a mobile phone. A mobile phone with Chrome. So we go to our testing system. The certificate has been signed by Komodo. We can see with Chrome for Mac or Chrome for whatever. So we go to the website. I've changed the certificate behind the scenes. So when you press F5 to refresh, you will see that it hasn't pinned what it remembers. And in iOS for Chrome, it takes it directly and it keeps working. I think I've broken something. No, it's running. This is Firefox now. Firefox on iOS. Same thing. The certificate is changed, not from Komodo anymore. It is now from GeoTrust. I do F5. Firefox tells me there is a problem with the pin. But with Firefox on iOS, no problem. By the way, if you have an iOS telephone, download Firefox for iOS and try to click on the green padlock. You will see nothing. That is broken. I don't know why it doesn't show information about the certificate. I don't know whether this is part of the latest release from Firefox. In theory, you should be able to see information about the certificate. You don't see anything. So, it doesn't work in iOS. Other stuff. We wanted to test it to see how this attack would work using Chrome in a mobile phone again. Basically the same story. We see Chrome using 14 megabytes when we do the attack. The attack will launch from our website with a man in the middle. The user visits the website. Look at the top. It starts consuming 1 megabyte per second. If I shut the browser off, it still consumes 1 megabyte per second, and there's no downloads. Apparently, because there's no arrows at the top. So you consume data. You can switch the application off, and Chrome will keep downloading to the extent that Chrome will go bust and still consume data. Finally, it freezes and everything breaks. In your mobile phone, obviously, you have less storage than in your desktop computer, and then your data plan will be impacted directly. So you're in deep shit, basically. a really cool thing Sheila was working on. She's a much better programmer than any of us. This is a small module for post-exploitation. Just imagine that the device has been infected. This is the module created by Sheila. This was created officially a very short while ago. This is what the module does in the device which is being attacked. Just imagine you're in front of the device and you want to capture passwords from the encrypted network, and for that you need an SSL script. An HTTPS is interfering, or HPHP. In that case, it will be very simple. You simply load the module for post-exploitation, or you load the interpreter in the infected computer. In this case, this is session 2. You run it, and you eliminate all those little files that I'm showing you now. The TXT for Chrome, for Firefox, for Opera. I know I'm the only person in Spain using Opera. I guess there must be other users of Opera out there. Anyway. So now you can do whatever you want. Launch any type of attack, because with a single click, all the cache was deleted. This is a way to make things simpler with a module for post-exploitation. There is something else. We don't really know how to use it to be evil in Chrome that drew our attention. This is another way to attack. You can configure your own recipe to inject pins, to inject HPHP, all the rubbish you want to inject. If I send one which is real, another one for backup ending in a 1, yes, it ends in a 1. I'm sending it through the header, there's no problem. These are the 2 pins, everything is correct. But if I go over here and I take a look at what was stored by Chrome, Chrome stores something that ends in a 0, not a 1. That was quite striking at first. I was wondering, how come it doesn't respect that hash? It's impossible. Doesn't make any sense. So after a lot of thinking, what I think happens here, well, this is base 64, and base 64 has some sort of padding at the end. Base 64 doesn't have a single relationship with whatever you're coding. There is a padding. Okay, depending on how you code. What could happen here? Perhaps Chrome is decoding it to 64 and then encoding it again. In that case, we'll have a 0 at the end, whereas you have a 1 at the end. How about using this to be evil? Well, because this is something that will never happen. You will never be able to calculate the certificate with just a 1 at the end. You will always have a 0 at the end because of that padding. I really don't know why it decodes and then encodes. Firefox respects this. Whatever you send is what it stores. But Chrome does a decoding, which is a bit strange. I'll have to keep investigating. And there's another doubt, something that comes up every now and then. How about incognito? Well, you know that HSTS were used for super cookies. It can be used to track users. HSTS was used to track users. This is not something we found out ourselves. We saw a guy serving you a unique pin backup. When you get a unique pin backup, it gets stored and you are tracked. How are you tracked? Well, there's something I haven't told you about. When HPHP shows you that the error telling you, hey, the certification string you are giving me is not the one that I am remembering. At that time, there is a trigger that goes off, which is this you're giving me these 3 certificates, which I understand are fake, I'm sending them somewhere. Where do you want to send them? There's a trigger there. So in order to track you, what you can do is to send yourself, to send you a unique PIN and produce a failure so that you send that unique PIN to yourself. So you end up being tracked. This was mentioned at the Talcom conference, and it's perfectly feasible. There is no solutions, so to say. But in the incognito mode, it doesn't respect HPHP anymore, or HSTS. Why? Because this wasn't the case before. In 2013, in fact, there was a discussion, an ongoing discussion, that said it should be the other way around. Why are you respecting my HSTS in incognito mode? Because you have access to all my history. You shouldn't have access to HSTS, so it was removed. Well, people are wondering, should it respect it? Should it not respect it? Currently, it doesn't respect it. One of the things that struck me, which is related to being tracked, is to induce a failure. What this website does is the following. A failure is induced. There is a PIN failure. The user sees nothing. As I understand it, here we should see an alert or something we should see an alert anyway, as we see in other websites. An alert telling you there are external resources in this website that are changing your certificate, but that is not shown in Chrome or in Firefox. The alert is shown here, in an area which is not visible for the user. This should be changed, in my opinion anyway. And finally, wget, it's got its typical txt file. It was included recently. We've tried to break it, to no avail. It doesn't support HPHP for the time being anyway. We took a look at the source code, and the only remarkable thing we found was this. I'm really wicked because I'm writing macros that change the control flow. But who will notice that? Well, I did notice it. So this is how it works. There's other ways to find a workaround. Scott Hellman mentioned this. But anyway, this is just an anecdote. Once you see the message telling you that a fake PIN has been used, there's no way you can access that unless you use the word bad idea, or the 2 words together. It gives you a safe conduct, so to say, for testing, which is active in Chrome. When this was known, and by the way, this has been like this for 2 years, they said it would change the word. This is source code for Chrome. They said it would change it and replace it with this. If you decode it, base 64, it says this is unsafe. So someone typing this is unsafe could circumvent the system. In case you're interested, here we've done lots of things. We've tried a lot of different things to break the system. It seems that this is stored properly. We've done 2 billion things here. And this is the most remarkable things we achieved anyway. Conclusions. The message, the take-home message, Firefox uses its own system with scoring that allows, on the one hand, to evict domains with a low score, and in practical terms, it allows it to reduce the database to 1 entry, constantly overwritten, by the way. Chrome allows as many headers as possible, literally, whatever fits into a header, and it makes it crash. I'm not sure about the wording. All attacks may be achieved via a man in the middle or not, simply by visiting a website. And both browsers, I didn't mention that during the presentation, for example, Firefox has problems with the pin. Everything gets together in the TXT, so it looks a bit odd. We haven't been able to be evil with this browser for that purpose, but anyway. Internet Explorer or Edge do not even work with not known domains, and we have created tools that are really cool to do a number of things: to check your local database with pin patrol, to test your database with cloud pinning, and to delete your database with a module for post-exploitation. So one of the conclusions is that we can tell there is not a strong bet yet for improving these implementations in browsers. Not yet, at least. I'm not sure about who is behind the scenes. These things we've been seeing for quite some time, and yet I haven't solved them. And then something I've been told I can mention is cancelling out HSTS. This is the initial name for my presentation. This is a verb which is really funny. So I was fascinated by that word, descansing, and I spent a few minutes to find out why the title for my presentation at router.com. In case you didn't get it, it took me a while. Descansing out. I've never heard that word. And people thought that I had invented a word. The key is here. How do you call this in English? Break. What does it say here? Breaking. So descanso means break in Spanish, so descansing means breaking. Whatever. A play in words. Whoever did this, well, I don't want to criticize them, but it was funny. It took me quite a few minutes until I realized that it was Spanglish. Descansing, what the hell? Whatever, it was Spanglish. That was it from me. Thank you so much.
Que sepas que le voy a decir a mi jefe que empecé a...
You must know that I'll tell my boss. Okay, replacing offers from Telefonica by offers from Orange. Questions? There is one over here. Any others? Don't leave the room. Hi. Please use the microphone. Perhaps I missed it, but you said you were going to explain why Google has forgotten about HPHP, and I have the impression that you didn't actually explain why. No, I didn't explain why. It's very cumbersome. You can shoot yourself in the foot if the certificates are changed and you don't pay attention to the backup certificate. You could do a ransom HPHP on yourself. You would block your users until they forget that PIN if you've made a mistake. And then administrators have no idea how this works. If you took a look at the configuration for HPHP, I can tell you, you will be fearful. There's so many uncertainties. People are getting really confused very easily. So this is not the best way to manage things. They will probably focus on certificate transparency, which is something I'm studying right now. It looks much better. It is not a PIN, but it does solve one of the main problems with TLS. I think there will be a combination. On the one hand, the big ones have not adopted this probably, and the Internet Explorer will not be doing it. Administrators don't really understand it. It is true that the system has a number of things that are quite complicated, and it hasn't worked properly. Oh, by the way, there's something else I didn't mention. This has been reported to Firefox, but they have ignored me completely. Okay, the email was ignored. someone, not even me, published comments in the forum for Firefox, and they didn't seem too interested in this. Okay? Any more questions? Hi, good morning. First of all, congratulations. I really enjoyed your presentation. Thank you. One question from me. If we use the preload, are we safe using HSTS? And if there's no preload in the other one, in HPKP, do we remove it or what? Well, with preloads, it should work. In fact, preloading is for this, to avoid this. Now, you have to wonder, who has preloads? And then who implements preloads properly? In theory, preloads has to do with two things, okay? It's not just using your preload in your header. You have to be in the list for preloading and do the two things. That is so cumbersome, so complicated. They conducted a study. There were some 6,000 cases and less than 2,000 could do it properly. We did it ourselves. You can see who has been preloaded and whether it meets the requirements to be preloaded, and most of them don't actually meet the requirements to be preloaded. And the second question on HPKP, whether we can remove it, I don't know what you mean. Since it doesn't have a preload, what do we do? In our website, do we get rid of it straight away? No one said it's a bad option. If you use it properly, it's a good thing. I don't think you should remove it altogether. And besides, this is a problem for browsers now because they're not implemented properly, but I cannot see why you should remove it if you're using it properly. But as I say, it is very complicated. Perhaps the effort you need to keep a safe and healthy HPKP in place doesn't pay off. So I would probably go to CAA. If you don't know what CAA is, you should focus on that. It's much better. Certificate transparency. CAA implies using something in one of your fields for the DNS, who your CA is, who your favorite CA is, and that will allow you to do your pins on your CA to make attacks more complicated, much more complicated. But now the CAs that issue certificates have to go to your DNS to check it. Not all of them do that. But if the question is, I'm administrating a website and I want to implement HPKP, go for CAA. Cleaner, safer, it's the future and it works well. Thank you. There's another question down below. Can you please raise your hand? Any more questions? There's another one over there. Hi, congratulations for your talk, for the contents and for the style, very entertaining. Well, hot topics basically. All of these attacks you've talked about, would they work with plugins like HTTPS? Everywhere. HTTPS everywhere. I don't really know how it works. This is what I think I would do. What I did at the start. When I looked at the TXT, I tried to force writing something on it, and it respected it. If you're storing something in the database, obviously it will not work. But I don't think it does it that way. I think what it does is use an internal forwarding, address forwarding. If it goes beyond the storage system for Firefox, it will work properly. Bear in mind that we are attacking the system itself, the storage system itself. I don't really know how HTTPS everywhere works, but there are two ways. Live doing 307 on everything, which I think makes sense. What it does is, with all requests, they are rewritten with HTTPS. Yes, it does 307 live. Perfect, that's a good idea. If others, and this is what I did at the start, how about we force on the TXT everything to go through HTTPS? That's a bad idea because this is what could happen actually. One very silly question, Sergio. With the post-exploitation module with Sheila, instead of deleting, why not adding? raise the service with an inverse proxy. If what you want to do is add things to the storage system in the browser, you will have a problem. With Firefox, if you try to add, it's more complicated. It's got a layer. It uses the layer and then stores. Chrome works differently. If you add to Firefox in real time, you will have a problem, but it's a perfectly valid idea. It makes sense. Any other questions? Great. Oh, there is a question over there. Hi, very good job. Thank you so much. I enjoyed it a lot. One question. In Chrome, in the desktop version, and the attack using HPHP, HPHP. In that, when you made the browser freeze, is it because of the administration tools? What do you mean? In the video you had the administration tools. No, I just wanted to show you what is happening behind the scenes. The user sees nothing. It's absolutely transparent. Bear in mind that you would need to press F12. If you have a lot of requests with the administration tools, and the administration tools are open, it will freeze. No, has nothing to do with it. It will happen all the time. In fact, we've done it in the browser, in the mobile browser, and there's no F12 there. Now we're done. Thank you so much, Sergio.